So here we have another problem, another previous problem from the topic laws of motion. So here how the problem goes is, you have a string of negligible mass. Remember, the moment they say the string has a negligible mass, that means it's an ideal string, right? Sometimes they'll also give, and mostly they should give, the string is of negligible mass and it's inextensible, right? That even more confirms that it's an ideal string. But even in this case, when nothing is given and it's only given that it's negligible mass, you can take it for granted that it's an ideal string. Sometimes even if they don't mention anything, you have to take a string as an ideal string. Only if they mention it's not ideal, which will most likely not happen, right? Then you should think of the string not being ideal. But here the string is ideal. What do I mean by an ideal string? An ideal string is a string where at every point the tension will be the same. So if the tension at this point is T, tension at this point, any point on the string will be T, right? That is what you mean by an ideal string. This is going over a clamped pulley. So that you have a clamped pulley here of mass m, right? Of mass m. And this ideal string is going over this, which is clamped, and it supports a mass of capital M, right? Suppose a mass of capital M as shown. Now the force on the pulley by the clamp is given by. So the force on the pulley by the clamp is applying some force on the pulley, and that is what we need to find out, right? So it's a very, very simple problem actually. How it goes is, when you draw the free body diagram for the small m, first of all, it's at rest, right? There is a tension which is acting on this, and this tension is the same tension which will act in this direction, right? On the pulley also, right? On the pulley also, because it's tension is always a pulling force. Remember, if there is an object and if there is tension acting on this, tension can never push this object, it will always pull, right? Tension always pulls the object, right? So this is how the direction of tension will be. So for this, tension will be equal to small capital Mg, and for the pulley, if I draw the free body diagram of the pulley, there is tension which is acting in this direction, there is small mg which is acting in this direction. What is tension for capital M? Tension is equals to capital Mg. Why is it capital Mg? Because the block is not moving, right? So that's why the forces have to be equal. So I can replace this diagram with this. So you have a capital Mg acting in this direction, because tension will be the same at all points, right? That is why they gave this thing, negligible mass. That is, you have to assume that the string is ideal, right? So this is capital Mg and this is small mg. Now what you have to understand is, the clamp applies some force on the pulley, because the pulley is applying some force on the clamp, right? And the same force will be applied by the clamp on the pulley, right? So there is some force F. Now because the pulley is at rest, these three forces vectorially have to add up to 0, right? So first of all, I'll calculate the magnitude of the resultant of this, and the magnitude of F will be the same as the resultant of this and this, but in the opposite direction. Only then it will be able to cancel. Only then the forces will be able to cancel. So F is equals to, I can say, mg of, so because this is mg minus I, F will be mg I, and this is small m, what do you say? This is small mg minus m, right? So this is small mg j. So this will be plus j, right? So the forces, and also, yeah, one more thing, there is also a tension which is acting on the pulley. So the string is pulling the pulley from both directions, right? Even from this direction, even from this direction. So this capital Mg is also acting in this direction. So it is not just this capital Mg is also acting in this direction. So m plus m into g is what is acting downwards. So your force, so what is the resultant of these? Basically this F dash. If I say the resultant of this is F dash, then F dash will be mg minus I plus mg minus j. And your F has to balance this F dash. F is the force which is coming from the clamp on the pulley, and it has to be negative of this. So that's why it is mg I and mg j, and you also have to have a capital Mg j, right? So your F will be equals to mg I plus m into g j. If you need the magnitude of this force, it will just be squared, right? So F magnitude is nothing but under root mg whole square plus plus m plus m into g whole square. So, you can take out g from this, and what you will get is m square plus m plus m whole square, capital M square plus m whole square. So, it is the fourth option.